How's it going, everyone? Today we're going to go over a practice question discussing the common ion effect. Pause this video, try the question on your own, and then let's go over it. So this question is stating that the solubility constant of barium sulfate, which is a common contrast agent used in fluoroscopy, is this number, which actually doesn't turn out to be that important. So if magnesium sulfate is added to a solution containing dissolved barium sulfate, which of the following would be true of the solubility of the barium sulfate? So this really gets at the concept of the common ion effect. And to understand the common ion effect, we have to understand what our chemical equation for the dissolution of barium sulfate looks like. So our solid barium sulfate will dissolve into barium, which would be aqueous, and sulfate, which would also be aqueous. Now, we can write our solubility product, which is just a KEQ, but because it's a dissolution of a solid, we label it SP as the concentration of our products over reactants. And because we can't measure the concentration of a solid, BaSO4 on our left, it's just going to be the numerator, which is a concentration of our products here. Now, in any chemical equation where we increase either the reactants or the products, we have a concept that we have to take into account called Châtelier's principle. And Châtelier's principle basically states that all chemical equations sort of work like a seesaw. If we increase or push up the seesaw on this side of the equation, we drive the reaction to the left. So I sort of think about it as if this were sort of a lever. If we were to push this part of the lever or this part of the seesaw up, we would drive everything to fall sort of over this way. And that's exactly what's happening in the common ion effect here. Because we're adding more sulfate that's going to dissolve, so magnesium sulfate has its own dissolution reaction where it's going to dissolve into some sulfate ions. We're increasing the amount of product here. So we're actually going to decrease the amount of barium sulfate that's going to dissolve in this solution. So this is one of the most common ways that the MCAT is going to test this common ion effect. It's really just a fancy application of Châtelier's principle, something that the MCAT really loves to test. Now there are some other ways that were a little lower yield that I didn't want to go over too in depth, but two other things that could potentially affect the KSP besides the common ion effect would be the pH of our solution. So the pH also has to do with Châtelier's principle, but in a more nuanced way. So for example, if we were to add hydrochloric acid and have some hydrogen ions to combine with sulfate, for example, and actually complex this together, that would actually decrease the amount of products that we had, because that would start to complex with the sulfate and reduce the amount of dissolved sulfate that we have, and that would actually drive the teeter-totter or seesaw over this way from left to right. So actually more barium sulfate would dissolve. Okay. And the third would be temperature. So generally when we increase the temperature, we're going to increase our solubility. Now remember, if we're increasing the temperature, we're no longer dealing with KSP or our solubility constant. We're really more dealing with Q because we've changed the standard conditions. Remember, KSP is under 25 degrees Celsius. That's sort of a presupposition that we go in with. If we increase the temperature, we're going to increase the solubility of whatever we're looking at.